Okay, so we're starting chapter 2, and actually the very first section of chapter 2 is really going to be revisiting something we talked about in chapter 1. Alright, so we're going to look at more with equations of lines. So we introduced the linear function in chapter 1. Right? We're still going to have the linear function. What we're doing is we're just going to look at lines in more detail in this section. We're looking at different equations that we can write, how we can write our line in different equations. Point, slope, intercept forms, and the standard form of a line. We're going to revisit horizontal vertical lines just again, because again, those typically are hard lines for students, so we'll visit it again. And then we're going to add two more new types of lines, parallel, perpendicular. And then the last thing we're going to do in this section is we're going to look at applications where my information on my scatter plot, we're going to do scatter plots too, where the information on my scatter plot is almost linear. And what we're going to do is we're going to find the best fit line to that almost linear data, and we're going to do that by linear regression. Alright, so the first thing, reminding you what the linear function is from chapter 1. So this is the one we get introduced in chapter 1. Y equals our function f of x, which is mx plus b. Well, I'm going to drop the function part. I'm just going to say y equals mx plus b. There's my linear equation, y equals mx plus b. That linear equation is called the slope-intercept form because that's what we're given in the equation, right? M is my slope, right? My change in y over my change in x, my rise over run. My b is my y-intercept. Alright, it's the point on my curve that crosses the y-axis, the 0b, which I can use that information to graph it, right? I could graph my point and use the rise over run to find a second point. So again, that's the same equation we had in the last one. There are two other ways you can write a line. Right, two other ways we can write a linear equation. The first one we're going to look at is what's called the point-slope equation. The point-slope equation is the point-slope because we're given the slope or can find the slope. And then we're given at least one other point on my curve, which is not the y-intercept. If it's the y-intercept, we'd put it in the previous equation, slope and intercept form. So this is a point that's just any other point on my curve. It's not the y-intercept, it's some other point. I'm either given slope or I can find it. I'm given 2 points and I can find it. And so when we write it in slope or point-slope form, right, usually this is the form we'll start with. This is the form if you've, again, taken algebra in high school. That's the form they talk about, where you take your difference in y. So you take your y minus your point y, so the y1 is a number, equals your slope, which you have, which is a number, times x minus the x value in your point. Alright, so y1, x1, and slope are all numbers. Alright, for some reason students like to get confused about this, and if you're given 2 points, they'll put in a value for just the plain x and a value for the plain y. But these are your variables, so they stay y and they stay x. Everything else, though, should be a number that you're either given or you found slope. Alright, so that's the point-slope equation. Then up top is the form where we've solved for y. And just so you know, this is the form that they're looking for when you're asked to put it in the homework on my lab. Right, when they say they give you 2 points, they want you to find the equation of a line and solve for y. This is the form they're looking for. You could take it a step further and put it in y equals mx plus b, right, which is also acceptable too. And actually, this is the one most of the time we prefer because it's what we consider the simplified form for a line. It's kind of like if I have a fraction, we always write in simplified form, right? If I have the fraction 4/8, I always write it as 1/2. Same thing for lines. If I have an equation of a line, the simplest form for the equation of a line is the y equals mx plus b because it's simple, it's in function form, so I can graph it really easy. Alright, and so it's just sort of the one that we like to have. Right, so I'm going to do an example where I'm going to walk you through this. Alright, so first thing I'm going to find is I'm going to find the equation of a line that passes through these points using the point slope, so I'm going to use this equation here. Then I'm going to solve for y, which is going to put it in this equation, which, like I said, this is what your homework is asking for, and then I'll take it one step further and put it in the simplified form, which is y equals mx plus b, which the homework will also accept the simplified form. Alright, so that's what I'm going to do. So starting off, I've got two lines that pass through, that my equation passes through. So I've got the point -2, -3, and the point 1, 3. right? I need to first always start with find the slope. Unless you're given it, always find slope first. Which, remember, it's the change in y over the change in x. So you take your change in y, which my y values are 3 and negative 3, so it's going to be 3 minus a negative 3, and then the change in x are 1 and negative 2, 1 minus a negative 2. Make sure you're careful, right? If they're minus and negative, it's really adding, so up top I get 6, and the bottom I get 3, and so always simplify. 6 over 3 simplifies to 2, so my slope is 2. Right? And so we always want to have a simplified answer for my slope. Right, now I'm going to use the point slope equation of my line. So now I'm going to use the y minus y1 equals m times x minus x1. And you can use either point. Doesn't matter. You could use the negative 2, negative 3, or the positive 1, positive 3. My rule of thumb is to use the positive values because you're less likely to make an error with negatives. I tend to lose negatives, so I avoid them when I can. It doesn't matter though. If you want to use the negatives, you can. It's the same equation. Once you simplify it, so y equals mx plus b. Alright, but I'm going to use the 1, 3 as my point. So my y value is 3, so it's y minus 3. Slope I found was 2. My x value is 1. Alright, so there's my point slope equation. Now I'm going to solve for y and get it into this form. Solving for y and getting it into that form. Which means I'm going to add the 3 to the other side. And so we get y equals 2 times x minus 1 plus 3, which again, on the homework, in my math lab, when they ask you to use the point slope equation to find the equation of a line and solve for y, that's a form that they'll accept, so you can plug that in. I am going to take it one step further and solve for the y equals mx plus b, which means I'm going to simplify this. It's sort of simplifying this expression. So to simplify it, I'm going to distribute my 2, so I'm going to get y equals 2x minus 2. I still have the plus 3 on the outside. Collect my like terms, so y equals 2x plus 1. And there is the y equals mx plus b. So my slope, which is 2, which it should be. And now I know my y-intercept is 1. Right, again, the homework will accept either one of those when I ask you this question, solve for y. Again, either one of those will work. You should be able to do both of them, right, but either one of those will work. Alright, the next way. So the third way, we can write an equation of a line. So we have the slope-intercept form, y equals mx plus b. We have the point-slope form, which I usually solve for y and get it slightly more simplified. And then the last way is the standard form. And we like the standard form when we get later on, we're going to solve systems of equations. Standard form is the way we're going to want to write equations in standard form. So standard form means I put all the variable parts to one side. So the x is the variable part, y is the variable part, and then I set it equal to a constant. Right, just a number on one side. Okay, so that's what standard form means. That's true for any equation in standard form. Variables on one side, constant on the other. So A, B, and C are all numbers. Right, A and B can't be 0 because I need an x value and I need a y value. C could be, though. The equation could be set equal to 0, and that would be fine. So an example of a linear equation in standard form would be 5x plus 3y equals 15. Right, my x and y values are on the left side. My right side is my constant, 15. Alright, solve for y and put it in slope-intercept form. Because a lot of times, if we want to graph this, you can't graph it unless it's solved for y. And then slope-intercept form allows us to also just, we know the slope, then we know the y-intercept. I don't know my slope when it's in standard form. I don't know my y-intercept when it's standard form. So in order to get the standard form, I have to solve for y. Alright, so 5x plus 3y equals 15. So first thing, move the x term over, 5x. So I'm going to subtract 5x. So I've got 3y left over here. I've got negative 5x plus 15, right? Those aren't like terms, so they're separate. So it's just negative 5x plus the constant 15. And if you write it the other way around, 15 minus 5x, that's fine too. Right? It's the equivalent if you do 15 minus 5x. Either form is fine. We just tend to write it in x first, constant second. Really doesn't matter in the grand scheme of things. but I will leave it in the y equals mx plus b because that's the version I want. Alright, next step is to get rid of the 3. This is the step you have to be careful of. I'm going to divide by 3, which means I need to divide everything by 3. Every part gets divided by 3. The y part gets divided by 3, the x part gets divided by 3, and the constant part gets divided by 3. Alright, I need to get rid of the times 3, and so what we do, I made it negative, we divide, and what you have to remember, when I divide one part of an equation, I have to divide all of the parts of the equation. And so that reduces to 1, leaves me with just y on that side. That I'm still left with the fraction, negative 5/3. And then this does reduce, so you should always reduce it, right? 15 is divisible by 3. I could take 15 divided by 3, and that comes out 5. And there is my y equals mx plus b. My slope is negative 5/3. My y-intercept is 5, or 0.05. Which again, that allows us to graph things for easier. It allows us to, know some important information about my lines, the way I can figure out my slope, which is important information. Alright, so we'll stop there. The next thing we're going to do is look again at finding intercepts, which again, not a new topic, something we did in the last section. So I'm going to hit it fairly quickly in this one.